Okay, so today we're looking at doing the regression line, or what it's often known as the least squares regression line. So you can see that written here, the least squares regression line. So what we're doing, we've got this scatter. We've been looking at this scatter plot, and we've made sure we've put the EV on the x-axis and the RV on the y-axis, and we've got this scatter plot, and we've looked at the R value, the strength of it, and we've looked at R squared. Now what we're going to do is it's like the line of best fit, similar, but it's doing that, but it's the least squares regression line. So it's where we try to balance out. Now, the least squares regression line, you can see that I've asterisked here. You need to just know that statement, but you've got it in your notes, because sometimes they'll say, what is the least squares? So it's the least square line is the line that minimises the sum of the squares of the residual. So you just have to know that statement. You can go look back and see if they ask you for it in a multi-choice, that's what it is. But let's have a look. What is a residual? Because they did talk about a residual. So if you've got your scatter plot here, and say I'm over-exaggerating my dots here. So what the least squares line does is it's trying to balance in those dots where it's going to minimise these distances here so that they all balance up. So that's what it's saying. Now that green line in there is known as the residual. So the distance between the actual, so the dot is the actual, and what that actual line of best fit, so the line value, so that is the predicted value. So you can see the dot would have this y value, and then so would the line, it would produce. So that distance in between the two y values of that, what they predict and then what actually is called the residual. So what you need to do, see there's a definition there. I would write, and I'm pretty sure you should too, under here, write in the data value, write that this is the actual, okay? And it say may be given, or you might say, or you might read off a table of values. So they might actually do that, or read the dot on the scatter plot, okay? So that's how you get that. You can get, there are ways of where you can be given the actual. So they might give it to you, they might say this thing actually had that. Now with the predicted, we're going to use the equation that we're going to find. So that the y equals a plus bx. So you use that to find the value of the predicted, okay? So we might have that formula. So obviously we're going to look into getting this equation, the least squares equation. So remember that the a is like the y-intercept, yeah? So what do I mean? If this was 0 down here on the x-axis, this value would be my a value, okay? And what did we say the b was? Yeah, good. So maybe just write that. So b is the gradient. Now, if you remember back, on our calculator, remember when we found the R value, there was also A and B were listed there. So you can get that there, you can get the equation there, or you can get the equation on the scatter plot, and we'll have a look in a minute when we do one on the calculator. So really important now is that if you don't decide which one's the EV and put it on the X variable, you will get the wrong equation. Yeah, the wrong A and B value. So some of you, did you notice it didn't matter for the R value as such? You still got the same thing, but it will matter for the equation. Now, when we do this linear line, so we're saying, because we're going to go fit it into this, we're saying it's a straight line. So if we're saying it's following a straight line, we're making the assumption that the data is linear. It's a linear pattern, okay? So remember, that could come up too. Remember when I said you can only use the R value if we're assuming it's linear, and it's the same with this equation. We're going to assume it's linear. And also, we don't want any outliers, because if the outliers will drag the line not out of whack, so we don't want that either. All right, so now there's a couple of ways of finding the A and the B value. So one way is finding it on the calculator. Another way is if they give you some information about the data that you've collected, but you don't have the table of values. So you might want to write a little note, because I often find kids forget about these formulas. So when you don't have a tables of values, don't have tables of values, and what's going to happen is they're going to give you this data. So you can see we've got a formula here for B, so a formula for the slope, and we're using the R value. Now when it says SY, so SY means the standard deviation of the Y list, or you might write your response variable. So maybe we should write that above or we could even do it here. You could do R times, if you want to write standard deviation of RV over standard deviation, I'm just abbreviating there, EV, okay? So that's what, they might give you this, so they'll give you it in a blurb. And that's how we find the B value. And then also we have a formula for the A value here. But can you see, because you use B, so therefore you must find B first if you've got to find both. Okay, so and down here, this should have a line above it. So you could, and the same, it's the mean of the EV and the RV. Okay, so, and that's, you can see that's getting used in the A formula. So down here, I've done a little example for you. It said the heights and weights of 11 people. So we've got two numerical, so we can use, do this least squares line, have been recorded. And they've told me here, so they've said the mean of X. Now they said heights was X, so they were nice for us and reminded us that height is EV and the weight is RV. So they've given me all those formulas, and it says use a formula to determine the equation of the least squares line. So as soon as you're in a question and you see that, just write above it, that means y equals a plus bx. So you know you have to write that out or use that, the formula. Okay, now I've just added into it to do 3 significant figures. You can't see that, so just down the bottom I've written that. So if we go, and here's where I've done this example, the working out. So you can see this is the R value they gave me, and this is the standard deviation of, our Y, which is weight. So I've used that over the standard deviation of our height here. So I found B, there's B. Now it says, I said to 3 significant figures, so I started counting as soon as I got the non-zero, so 1, 2, 3. And because that number after 7 is a 3, I don't need to round up. Then I've found the A formula, and you can see I've used the B value. I've just used the answer that I found before. Don't worry, they'll be very clear on which number to use or rounding, okay? So I know, say some of you might have used the non-rounded, so they'll be a bit more clear for you, but I just used it for this example. All right, so I end up with a Y, the A value being negative. Now, I've got 3 significant figures, so I start counting as soon as I have a non-zero. So that 8, 4, and then I've got the third. So I looked here, and because it was a 7 after the other 0.7, so it had to go up. Okay, so then it said to write the equation, so you must now write it out fully in words using your variables. So I'm no longer using y. You're going to put the response variable there, and the units in brackets is often good to pop there. And you can see here's my A, here's my B, and then here's the EV. And I'm sorry, the units are a bit squiggled there, but it is in centimetres. All right. Okay, so here's a couple of exam questions. So it says the statistical analysis of a set of bivariate data involving X and Y resulted in the information displayed. So here you can see they've given you everything you needed. So using this information, the correlation coefficient for this set of data is closest to. So if you remember, back in our B formula, just that we did, it actually has R in it. So because they gave me the least squares regression line, they told me the B value here. So I can pop that into this formula. So you see I've put B, so B equals, and R's what I want to know. So there's my unknown. And I did know the SY, they told me that. And I've popped in, so I've popped in all the other details. Now, because I only have R missing, you can use your solve function. Everyone know how to use solve? Yeah, menu 3.1. So just pop it in your solve function, and that way we found R. So this is like sort of the new little things they're doing now. They were doing just find the equation. Now they're just sort of playing around with this formula, giving you other bits and trying to find it. So then if you look at the next exam question down here, it said a study was conducted to investigate the effect of drinking coffee on sleep. So sleep is what they're looking at. They want to see what's the response to sleep. So go down there and definitely write above that sleep is your response variable. This is crucial that you need to do this. And then coffee, the amount of coffee is the EV. And then once I do that, what I do is I write next to it what that, if it's RV, then this mean must be the Y mean, and the coffee must be the X mean. And I've popped that in, and there's the R down there. Now, it says, the question says, on average, each additional cup of coffee drunk, the amount of sleep. So when you see the word on average, that is another way of saying the gradient. So when you describe the gradient, you generally are saying that this equation is changing by this much for every bit. So on average, so that was a way of saying they wanted the B value. And then you obviously can use that formula again, and you've got all the pieces of information. So we have the R value, we had the SY, that was the sleep, and we had the SX, which was the standard deviation for the coffee. And we end up with a negative. So if you have a negative gradient, so if you think about your equation, I'm just going to write it up here. So what happens is if your X keeps going up by 1, whatever it is, 1 unit, you're going to change your Y by whatever the B is. So because it's negative, that means the Y will decrease. Every time we put 1 more on X, it means it'll decrease by 0.55. So a negative means decrease, so you can see that's how I found that answer. Okay, so the least squares line, so you'll see that that's just a way of them saying that Y equals A plus BX is fitted to a set of bivariate data and the X and Y, and they gave you all the details, and they've said the slope of the least squares line is. So you need to find the slope. Okay, and if you look, they gave you the A value. So the only way I can find the B, which is the slope, is by using that A value formula. And once again, I pop all the data in and I'll do solve. So there's a way I'm triggering. So somehow you're going to be able to use one of the formulas to work it out. Now, just to go over this question about least, so the least squares line has been used to model the relationship between average temperature and latitude at different weather stations. So they've found it. So this was Y, this is A, this is B, and this is X. Now, then when the numbers in this equation are rounded correctly to 3 significant figures. I'm going to pause for a minute and let you guys have a go. Okay, so boys, if I'm looking at the A value here, it's 42.9842. Okay, if I'm doing 3 significant figures, I count as soon as I get non-zero. So that would be 1, 2, 3. Okay, you have to look at the fourth one to see whether you round up. Now, that means I have to round up. So this number has to round up, which if it goes up, then that means this one goes up. So this one, for 3 significant figures, will have to be 43.0. Okay? Then, so the rest of the equation, and then if we look at the B value, which is negative 0.8774, so you don't start counting until you get the non-zero. So there's 1, 2, 3. Now, because the fourth one is under 5, that means that 7 can stay. So it'll be minus 0.877 times the latitude. So that answer is E. Oh, sorry, yeah, is E. Okay, let's do this last question. In a study between person's height and body surface area in square meters, the following least squares line was attained. Which of the following conclusions can be made from the least squares? So let's have a look. An increase of 1 meter squared in body surface area is associated with an increase of 0.19 in height. This is not true. So when they say an increase, when they're saying if you're increasing something or decreasing something, you want to be doing the X value. So not, here they're talking about they're increasing the Y. So get rid of it. It's a stupid statement. You don't want that. So now it says an increase of 1 centimetre in height. That's okay. So if I increase this by 1 centimetre, they're saying is associated with the body surface area, the Y, increasing by 0.19. And that is true because that's what the gradient is. Okay, so that's a way of describing, and it's increasing because the gradient's positive. So this is a good answer. The correlation coefficient is not that. That's the B value, so get rid of that. That was no true. A person's body weight in square meters can be determined by adding 1.1 to their height. That's just wrong. You can't just make all of a sudden someone's height becomes, this is just that was sort of like what we were talking about, correlation or causation. That's a causation statement. A person's height in centimetres can be determined. This is another causing. They're saying it's the cause. We can't say that anyway. So B ends up being the best answer there.